error you can have. Okay?
Not exactly what I was asking. I just wonder, like,
Oh.
do you have, like, if you're building a tunnel, do you have to get a surveyor of the first order?
No. You could get any old surveyor.
I only
They're
work in the
licensed.
first order.
But they're only allowed an error of producing an error of 1 part in 100,000. Okay, so it's not a good question. First order, second order, third order is not an adjective describing a type of surveyor. It's the adjective describing the allowable error that you could have. Okay, thanks for repeating the question. Obviously, I didn't get what your question was. Okay, second order examples are large construction projects, interstate and highways. Large construction projects, interstates and highways. And I don't have a distinction between class 1 and class 2. So just second order, large construction projects, interstates and highways. Highways. Third order, small engineering projects, small topos, small engineering projects, small topos, and boundary control. So property surveys, small engineering projects, small topos, and boundary control, property surveys. So let's compare the error there as opposed to what we are. What error were we allowed in taping? 1 in 1,000. So I'm giving you a big error, huh? Okay, what about leveling? Leveling, it wasn't represented 1 in something, it was 0, 1, minute, times, radical, and the number of setups, correct? But during the course of the semester, we're gonna see different errors that you're allowed, particularly for Saturday's lab, okay? So this is one sheet I had missed going over with you. But we'll always tell you what you're allowed, what the allowable error is. Now this is for horizontal control, and then here is for vertical control. So an example of vertical control is, what did you do that was vertical control? Leveling. Okay, so here's the error. The textbook had something in a little bit different. It's just a little bit different value, so I wrote down what the textbook had in addition to what I found. Okay, but notice this is in metric, right? Millimeters, so you'd have to convert it. And the K distance is between benchmarks, and it's in kilometers. We're going to see this more often. Okay. Okay, any questions on that? Yeah.
So like if you're to build your own house or something, right, you mark corners, that would be in the third order.
Right.
Okay.
And I don't know which one, first class or second. Is it first class or second class?
I don't know.
No, I mean, is the wording first class?
Class 1.
Thank you. The first class didn't sound right to me.
Third order.
Class 1 and class 2.
Third order.
So your home would be second class, I presume. Third order, second. If you do mark
I don't know
corners.
the distinction between the two classes, I just know the examples.
Okay.
So I just know the third order, so I'm not sure if it would be class 1 or class 2. There's another sheet in your packet that we don't need to do. This is, I meant to pull it out, but I forgot to pull it out. This is how to read a transit, and we're not doing transits. I mentioned the first day of class that transits are not used anymore. Transits are not covered on the licensing exam for the land surveyors, and they're not covered on the licensing exam for civil engineers, so we are omitting it. Okay, so where we are now is we're back to the traverse. So we did number 1, you did number 2. Hopefully you came back to the bearing of line AB. Did everybody check their stuff and come back to that bearing? So now what we're looking at is number 3, which was the last thing we looked at before we came in. So number 3 says determine the coordinates of point A, B, C, D, and E, with A being 0, 0, and determine the closure error. And I mentioned that when we write it in parentheses, I'm teaching this class as if you're coming from math, because most of us are most comfortable with math. Some of you are coming from surveying, so you might have like, who earlier today when we were out there, somebody said north is first, Brian, was that you?
Yeah, but that was
Yeah.
just a.
But it's
Yeah,
true,
I
in
misspoke.
surveying, when you represent a coordinate, you do say northing and easting, northing and easting. So you always give the y value first and then the x. But we're coming from math, most of you are coming from math, so if we represent them with parentheses and a comma between, we're representing them as x and y. But if we were doing, if they were asking you what the northing and the easting is, you'd have to represent the y value first. Okay? So I'm starting with the coordinate of A, of 0, 0 for A, just so that we can get more of a feel for the numbers, because we all in math always start with the origin and work it around. So I'm going to walk you through the calculations. They're all here in the packet, so you don't have to write anything. So we're going to look at this. I already mentioned traverse is a closed loop, and we're looking at the coordinates. So the x-axis is positive, y-axis is positive, it represents east and north. But two terms you need to know. When we're looking at the distance along the xy, which is the east, it's called departure. And the north-south is latitude. So you might have heard of, latitude and longitude. We're not dealing with latitude and longitude, we're dealing with departure and latitude. And this is maybe a little funky, but the way I remember which one is a plane first departs this way and then it goes up. So I remember departure as being the x and then going up. But, I know, weird, but
Well, like
remember
latitude's
it any way you want.
Latitude is the same, but because we're not doing geodetic surveying, we can't use longitude.
Okay, so latitude is up and down.
Right,
Okay.
it's ladder.
Latitude is the ladder.
That's what I remember about it.
Good, that's a great way of remembering it. And it's not really, we're not talking about elevation, right? When we talk about, we're looking at a horizontal plane of north, south, east, west coordinates, right? So we're still on the horizontal. So that's a good idea, a ladder up. Latitude, like latitude and longitude. Okay, so we're setting up everything from 0, 0. So to begin with, A has an easting of 0 and a northing of 0, right? And then remember, we were out in the field and we did this. We laid out line AB. We had a distance of 567.35. We said the distance this way is the change in x, which is called departure. And then this is the change in y and latitude. And you could use whichever angle you want, just be careful. So one source of error on this is that people use the angle and then use the sine or cosine wrong. So just be careful. You know cosine and sine already. So the fact that I'm using this angle here at B, would the change in x be a sine or cosine? Sine. And y would be cosine. Okay, so I calculated the departure, which is the change in x. I calculated the latitude, which is a change in y. And I noticed as I go from A to B, I'm going in the positive x and the positive y, so I have to put in positives. That's another big source of error. People forget to put in positive and negatives. So as I go from A to B, I'm going in the positive x and the positive y. So what would realizing that the departure is 457.94 and the latitude is 334.91, what would be the coordinate of B? 457.94, comma, 334.91. Okay, so now we have the coordinates of B, and now I'm going from B to C. And I happen to choose this angle. So the change in x, is it going to be sine or cosine? I'm using this angle, 5126. Is it change in x sine or cosine?
Cosine?
Sine, it's the opposite. Change in y would be cosine. Going from B to C, am I going in a positive x?
Positive x.
Positive x, but negative y. Remember to put in the positive and negatives. Okay. So I get a departure of 633.89. So I'm going to add that to the coordinate, the easting coordinate of B. So 457.94 plus 633.89, I get a coordinate of B of 1091.83 in the east. Then I'm going to take the northern coordinate, 334.91 of B. I'm going to subtract 505.40, I think that's an 8. And I'm going to get a negative 170. So which direction is it really going in if it's a negative?
South.
It's going south. Is everyone following? Questions? Brian?
No, it makes sense.
Yeah? Jason? You didn't nod, so I want to check in, you're fine?
Yeah.
Daniel, fine? Okay, so now we have the coordinates of C. I'm going from C to D. Is X positive or negative? Negative, why? Negative. I'm looking at the angle of 4138, so is change in X sine or cosine?
Sign.
Sine. Change in Y? Cosine. Calculate the departure and latitude, make sure I put the right sign in. They're both negative, subtracted from the coordinate of C. Now I get my coordinate of D, and then I go from D to E. Is X positive or negative? Negative. Is Y positive or negative? Positive. If I'm using the 4110 angle here, change in X, sine or cosine?
Sign.
Sine. Change in Y? Cosine. So those are the two mistakes people make. They use sine or cosine, they use the wrong one, and they forget to put in the negative or positive. Okay, so just watch that.
In this case, would delta y be negative because we're using point E as a reference?
No, we're going from D to C, going from, I'm glad you asked, going from D to E, I'm going up.
Okay.
Okay? I drew it left and right because the drawing has DE going from the lower right. I want to draw it in the direction it's going so that I know whether it's positive or negative. I'm going from D to E. Just like I went from C to D. And now I'm going from E to A. X is positive or negative? Negative. Y is positive. And what should I get for A?
0, 0.
I should get 0, 0. And what did I get? 0.0306, right? So I got an error in the X of what? 0.03, and I got an error in the Y of 0.06. So let's take a look at where I am. Oh, yeah, oh, yes, oh, I'm so sorry. Oh, thanks. Sorry about that. Okay, so here's my A initial. Everybody's comfortable with A sub I, A initial. In the end, I got A final to be positive 0.3, so over here and up here. So isn't this where A final is? Right? And the distance in the Y, the error I have is 0.007, and the error in the X is 0.003, right?
0.06.
Oh, thank you. 6. Okay, so I have an error in the X of 0.03, yeah, 0.06 in the Y. So really, doesn't this really represent what the error is? Right, it's the distance between these 2 points. So I used Pythagorean theorem, and I got a total error of 0.007. But now going back to the problem, let's go back to the picture. I went 567 feet here, 810, 922, 411, and 588. In all that distance I surveyed, I made an error of 0.07. So let's see what that error turns out to be. So the total distance, it's written right here, 3,300. So the error that I got was 0.07 over 3,300, which turns out to be a 1-foot error in 47,000 feet. But the allowable was 1-foot error in 10,000. Am I okay?
Yeah.
I'm okay. Okay, so just like you did before, you got an error, you compare it to the allowable, and then what do you have to do? Distribute it. So we have 0.03 to distribute in the X, and we have a 0.06 to distribute in the Y. So I'm going to show you how to do that now. Is everybody comfortable with the coordinates? Okay, now, surveyors and civil engineers really don't like to use negatives. They prefer to use positives. But we got negative coordinates, didn't we? Right? What could I have done instead of choosing a 0, 0 as a coordinate of A, what could I have done? I could have put it somewhere else, 5,000, 5,000. Many times when you're going out in the field to survey, the coordinate you choose for the first point is 5,000, 5,000, or if it's a really big area you're working with, maybe 10,000, 10,000. Because they prefer to work in positives.